Hello and welcome to this lesson about linear two-variable inequalities. The learning target for this video is graphing linear inequalities. First, I want to start off with a core idea, and that is that a graph is a picture of the solution. So for example, when we had something like y equals x plus 1, and we go and we graph that on a coordinate plane, this line that I just drew is a picture of all the xy's that work, all the xy's that are a solution to that. The same thing is true when we have something like x is less than 1. We go to a number line, we put a number on our number line, open circle, go to the left. This, the yellow line now, is a picture of all the solutions that work for this inequality. The same idea is going to apply here with linear inequalities of two variables. And so what we're doing is we are combining both of these concepts together. So we're going to combine them to where we might have something like y is less than x plus 1. We have two variables in one inequality. And so we're going to borrow ideas and practices from both of these skills. But it all hinges on the idea that, again, a graph is a picture of the solution. So let's talk about details and examples. More so, let's kind of focus on the process. So the first thing we need to do is graph the function. Now, this is where we use any method that we can to graph it. If it's given to you in slope-intercept form, use slope-intercept form. If it's given to you in standard form, find the intercepts and then graph it. Second, we have to be mindful of the line. So we have to ask ourselves, are we going with a solid or dashed line for the line of the equation? So solid line is going to correspond to less than or equal to or greater than or equal to. Just like how if we were graphing a linear inequality, if we had something like x is less than 1, you have an open circle. If you have x is less than or equal to 1, you have a closed circle. So a solid line is going to come from a less than or equal to or a greater than or equal to, and a dashed line is just a less than or a greater than. And again, that corresponds to this idea right here. Third, and this is something that tends to sort of students tend to trip up on, is test an easy point, not on the line. So we can test any point we want except for one that's on the line. And so the one I always recommend is to test 0, 0, because it can't get much easier than that. However, if the line is going through the origin, you can't. So then test something else that's easy. Go 1, 0, or go with 0, 1, or go with 1, 1. You have a lot of options. And what's going to happen is you test a point, and then you're going to, step 4, shade the true side. So we're going to take the coordinate plane and we're going to cut it in half. One side will be the true side, the other side is the false side. So when you test a point, if it doesn't work, that's the false side, meaning the other side is the true side. So what we're going to do now, run through some examples. So let's say we need to graph y is less than or equal to 2x minus 5. Okay, so let's go through it. What we're going to do is graph it normally. So we have this in slope-intercept form. So there's my intercept, -5. My slope is 2. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, down 2 over 1, so on and so forth like that. All right, now here's where again I have to be mindful. I have to look at this. Am I going with a solid line or a dashed line? This tells me that I'm going to have a solid line. So I'm going to draw my line all the way through like that. Perfect. Now I have to do testing a point. 0, 0 is not on the line. So I'm going to test this. So that's the one I am testing. So what I do is I'm going to write test 0, 0, and then I go 0 less than or equal to 2 times 0 minus 5. This is why I like testing 0, 0, because essentially I don't even need to write the x part because it disappears. 0 less than or equal to negative 5, question mark, that is false. So this is the false side of the coordinate plane, meaning that the true side has to be over here. And I will shade that. Now another way you can look at this is that the inequality itself is less than or equal to, meaning I want values that are smaller than it. And those values are going to be underneath the line. And again, we have to keep in mind that this graph here, everything I am shading, is a picture of the solution. I can pick any one of these points in here, including the line itself, and it will make the inequality true. Now, let's just walk through a few more examples. All right, in this example, I have y is greater than x minus 4. So again, it's in slope-intercept form. I will go to negative 4 on my y-axis, and then I'm going up 1 over 1, up 1 over 1, and whatnot there. So I've got plenty of points from which to draw my line, but I got to ask myself, what kind of line am I drawing? And since it's not equal to, I'm going to have a dashed line. Oops. That's how I spell line. There we go. So I'm going to draw a dashed line that looks like this. And bear with me, my stylus isn't the best for this, but you kind of get the idea there. There we go. Okay, so we have a dashed line. Next, I'm going to test a point. And I'm going to test 0, 0 again. So test 0, 0, and I get 0 greater than negative 4. That is true. Okay, so since this is a true statement, I'm going to shade everything above the line. And there we go. And so that's how it works. If this side is true, the other side is false, and we always want to shade the true side. And the test is going to tell us whether or not whatever point we picked is on the true side or the false side. And again, this is a picture of our solution. Now the difference is I can't take a point on the line. So I can't take something like 1, negative 3. If I take 1, negative 3, it's not going to work. I'll have negative 3 greater than 1 minus 4, negative 3 greater than negative 3. That's not a true statement. All right, that is false. So again, I can't use a point on my line, but I can get really close to that point on my line. And then again, I can take any of these other points in the shaded area, and they all make this inequality true. Okay, the testing for something like slope-intercept form might seem a little silly because, again, greater than means above, less than is below. But when you're dealing with different slopes and whatnot, it can get really complicated. And eventually, when you get to systems of linear systems of inequalities, then you might want to be able to have this idea of testing in your back pocket because that can really help you. And testing can also help when you're given something that's perhaps not in slope-intercept form. So let's say we have something like 5x minus 6y is greater than or equal to negative 30. So here we could do a lot of work and try to figure out what this is in slope-intercept form, or we could just do this using the intercept method, x, y, 0, 0. And if I do that, I end up getting, let's see, so if I let x equal 0, I have negative 6y is greater than or equal to negative 30. And so that means it's 5. And then if I let y be 0, x would have to be negative 6. Negative 6, 0, 5, 0. All right, well now, greater than less than, because if I were to have to move this over or divide by negative 6, I might have to flip my inequality. And so again, we make mistakes. It happens. Maybe a little bit easier is to test a point. So we go test, and again, first, look at the inequality. It's got an equal to, so it's going to be a solid line, and it's going to continue to go like that. All right, good. But then I test 0, 0, because it's not on my line. It's over here. It's super easy. It's easier than having to move everything over to one side. So for example, I'll get 0 is greater than or equal to negative 30. Question mark, true or not? It is true. So this is the true side, and this is the side that I'm going to shade. And there we go. Just for the sake of being thorough, we'll do one final example. So let's say I have 3x plus 4y is greater than 24. Again, if I wanted to, I could put this in slope-intercept form, but that's a lot of work when I could just go x, y, 0, 0. 0's in for x, y is going to be 6. 0's in for y, x has to be 8. So 8, 0 right there. 6, 0, or 0, 6 is right there. Now I look at my inequality. It is just greater than, so I'm going to have a dashed line between these two guys. And sorry about my line not being terribly straight. Easier to do with a ruler, pencil, and paper. But anyways, I've got my line, and now I got to test the point. And by testing, again, I'm trying to make my life as easy as possible. So here I have 0, 0, and I'll get 0 greater than 24. That is a false statement. So this is the false side, meaning the other side has to be true. I shade that right there. And that's it. That is how we deal with inequalities. The one thing I'm realizing I didn't mention is what to do if like the line is going through the origin. If the line's going through the origin and you want to test a side, what you can do is just take that point. You can take that point. You can take that point. You can take any point you want that's not on it. Keep the numbers small, maybe keep them positive, and then just try, see what happens. But it's the same idea. One side will be true, and one side will be false, and the other one has to be the other one. So good luck with your homework and practice, and let me know if you have any questions.